Okay, let's do some review with confidence intervals. In a survey of 1,002 people, 701 were registered voters. Construct the 99% confidence interval for the proportion. Well, clearly we're doing confidence interval for proportion. So we'll find the margin of error, and that will allow us to get the confidence interval. If we go to the formula sheet, the margin of error is equal to now the information we have in this problem. N is our sample size, which is the total 1,002. X is the number of successes, that is the 701 registered voters. Our confidence level is 99%. At the moment, all we have is in the sample size. We can find Z sub C using the confidence level. If we go to the standard normal table, the Z critical value for 99% is 2.575. Next, we need to get P hat. P hat is X over N, or just think part over total, 701 over 1,002. .7. Remember, Q hat is simply 1 minus P hat, which is 1 minus 0.7, which is 0.3. And now we have everything we need to get the margin of error. Start with what's under the square root. Margin of error is 0.037. Now, we will get the confidence interval, take your sample proportion, add and subtract the margin of error. Which gives us a confidence interval of 0.663 to 0.737. Now we can check our solution on the calculator. If we go to Stat, use the arrow over to Tests, scroll down until you see one proportion Z interval. X is the number of successes, which is 701 in this case. N is the sample size, which is 1,002. The confidence level is 99%. And there we can see our solution. Okay, in question 2 here, we have 1,025 randomly selected adults were surveyed, 29% shop online. Construct the 99% confidence interval for proportion. This is going to work very similar to question 1. They've just given us the data in a different format. We'll use the same formula. So in this case, we have that n is 1025. What we don't have is x, the number of successes, which is okay. We can find it. We know that 29% shop online, which is 29% of this total. So we find 29% of 1025. So if we convert that to a decimal, 0.29, and multiply, now we have a problem here in that the number of successes must always be a whole number. So we'll round this up to 298. Like the previous problem, the confidence level is 99% this time, which means the z critical value will again be 2.575. We have the sample size, we have the z critical, we need p hat and q hat. Now, in the previous problem, we used x over n, which you can use this time, but they've already given us p hat in the form of a decimal. And again, we can get q hat by doing 1 minus. And with that, we have everything we need to get the margin of error. The margin of error is 0.036. To get the confidence interval, we do plus or minus from p hat. .254 on the low side and 0.326 on the high side. We can check our solution in the calculator. If we again go to Stat, Tests, and go down to 1 proportion z interval. Now, be careful when you're putting this in a calculator. X and n must always be whole numbers. So if we come up with an x, like here we had a decimal, make sure you round that up. So x this time will be 298. The total is 1025, and the confidence level is 99%. And there we can see the solution. Okay, in question 3 here, we have the famous geneticist, Gregor Mendel here, conducting experiments on peas. In the sample, there are 428 green peas, 152 yellow peas. Construct the 95% confidence interval for the proportion of yellow peas. So similar to question 1 and 2, we're doing confidence interval for proportion, so we'll use the same formula. Okay, now we have to be careful with the inputs here. They say in the problem that they're 428 green peas, 152 yellow peas. Now they want us to construct a confidence interval for the yellow ones. So this, the number of yellow peas, is x, the number of successes. For n, the sample size is going to be the total number of peas, which is the green ones plus the yellow ones. Which is 580 total. Now that we have this information, now we can solve the problem like the other two. We have the sample size. The confidence level is 95% this time. If we go to our z-chart, 0.95, the z-critical is 1.96. Let's calculate p-hat. The number of yellows is the number of successes, which is 152, over the total 580. Zero 0.262. P-hat is 1 minus 0.738. And with that, we have everything we need to use the formula. Z critical is 1.96. P is 0.262. Q is 0.738. Over the total of 580. The margin of error is 0.036. Plus or minus from p-hat. Which gives us a confidence interval of 0.226 and 0.298. Now, if we check our work on a calculator, again, we'll go to Stat, Tests, 1 proportion Z interval. X is 152. The total was 580, and the confidence level this time is 95%. And there's our solution. Okay, in question 4, we have this ecologist who's measuring the temperature of this pond every day for 61 days. The mean temperature is 34 degrees Celsius. Assuming sigma is 1.7 degrees, find the 95% confidence interval for the mean. Now, we have to be careful with confidence interval for the mean. We have two formulas. In this case, we have been given a population standard deviation, which means we're going to use the Z distribution. So if we go to the formula sheet, margin of error, Z critical times sigma, over the square root of n. We have been given a sample mean of 34 degrees. In the sample size is 61. And we're told the population standard deviation is 1.7. We have this, we have this. We need to find z critical. The confidence level here is 95%. If we go to our z table, the z critical value for 95% is 1.96. And then we have everything we need. Which gives us a margin of error of 0.43. Now, if we get the confidence interval, we'll take our sample mean plus or minus the margin of error. Which is 34.43 on the high side and 33.57 on the low side. To check this answer on the calculator, we again go to Stat, Tests. Because we're using z in this problem, we're going to go down to z interval. You'll have two choices between data and stats. Stats is what we want. Population standard deviation is 1.7 degrees. The sample mean is 34 degrees. In the sample size was 61, and the confidence level was 95%. And there we can see the solution. In question 5, park rangers monitor the weights of bears every season. A sample of 54 weights are collected with a mean of 182.9 pounds. Assume the previous year's data has a standard deviation of 121.8 pounds. Construct the 99% confidence interval for the mean. Now we're clearly doing confidence interval for mean. Should we use z or should we use t? Here they say we have the previous year's data. We're going to assume that that is population standard deviation, which means we're going to use z. From there, we'll use the same formula as the previous problem. We have a sample mean weight of 182.9 pounds. Sigma, population standard deviation, is 121.8 pounds. The sample size is 54. The confidence level is 99%. We have most of what we need here. Again, we need to find z critical. If we go to our z chart, For 99%, the Z critical value is 2.575. So, if we plug everything in, we get a margin of error of 42.7. To get the confidence interval, we do plus or minus from the sample mean. Now again, we can check the solution in the calculator. Go to Stats, Tests. Again, we're using Z interval. Standard deviation this time was 121.8. Sample size was 54. Sample mean was 182.9. Confidence level was 99%. There's our solution. Okay, on question 6. Physician is conducting a study on average female heart rates. He measures the heart rate of 40 healthy females, and the data has a mean heart rate of 76.3 beats per minute and standard deviation of 12.5 beats per minute. Construct a 95% confidence interval for the mean. Now, we're given a standard deviation. This standard deviation comes from his sample. He measured these heart rates of 40 people, computed the standard deviation from there. This is S. Sample standard deviation, which means we need to use the T distribution here. If we go to the formula sheet, you'll see a very similar formula for the margin of error. In this problem, the sample size was 40. The sample mean heart rate was 76.3. Sample standard deviation is 12.5. Confidence level this time is 95%. We have the sample size. We have the sample standard deviation. We need to find T critical. So if we go to our table, and we go to the T distributions, we'll see level of confidence at the top. In this case, we're doing 95%, so we'll go to the center column. We need to have degrees of freedom. Degrees of freedom, remember, is just n minus 1, which is 40 minus 1, which is 39. So on our table, we go to 0.95 in the center, and we go down to 39. The T critical value here is 2.023. Now we can use the formula. Get a margin of error. Do plus or minus from the sample number. 76.3 plus or minus 4, which makes 80.3 for the upper, 72.3 for the lower. Now, if we go to the calculator, go to Stat, Tests, we need to scroll down, and we're going to use T interval this time. Again, you want it on Stats. The sample mean was 76.3. This S sub x is our sample standard deviation, 12.5. Sample size was 40. Confidence level was 95%. And there's our solution. In question 7, studies conducted to estimate hospital costs for those who wear seatbelts. 20 cases were examined, and the data follows a normal distribution with a mean of 9,004, standard deviation 5,629. Construct the 99% confidence interval for the mean. So, again, we have to look at this standard deviation that we're given. This standard deviation comes from the sample. Therefore, this is S, which means we need to, again, use the t distribution like the previous problem. We'll use the same formula. So here, we have a sample size of 20, a sample mean of 9,004, and a sample standard deviation of 5,629. Confidence level is 95%. Well, in the formula, we have the sample size, have sample standard deviation. Let's find t critical. To use the table, we need degrees of freedom, which will be 20 minus 1. If we go to the t distribution, again, we're using 95%. So we're going to go to the center column here. Go down to degrees of freedom of 19. The t critical value here is 2.093. Which means we have enough information to use the formula. Okay. Now that we have the margin of error, we can get the confidence interval. We can check this on the calculator. Stat, test, again, t interval, stats. Sample mean was 9,004. S, sample standard deviation, 5629. Sample size was 20. Confidence level was 95%. There's our solution. Okay, question 8. Physician is studying the heart rates of employees in labor-intensive jobs. 10 employees are surveyed with a mean of 175 beats per minute and a standard deviation of 15 beats per minute. Construct the 99% confidence interval for standard deviation. Now, if we go to the formula sheet, we have this long formula for the confidence interval. Well, we know the sample size is 10. The sample standard deviation is 15. So we have this. What we are missing are the chi-squared critical values left and right. And for this, we'll need to draw the picture. Now, we have a confidence level of 99%. On your figure, confidence level goes in the center. If there's 99% in the center, it means there's 1% left over in the tail. We split that evenly two ways. So there is 0.05 here and 0.05 here. We need these areas if we're going to use the tables. Let's start at chi-squared right. We need the total area to the right, which in this case is 0.05. N is 10, therefore degrees of freedom are 9. The area to the right is 0.05. We go to the 0.05 column on the table. We go down to degrees of freedom of 9. The chi-squared right critical value is 16.919. Now let's be careful here. If we go to chi-squared left, we need to know the total area to the right, which is going to be the 99% in the center plus the 0.05 over here, which means the area to the right is 0.995. So if we go to the 0.995 column over here, degrees of freedom are 9. The chi-squared left critical value is 1.735. There's a mistake here. This should be 0.005. Let's fix this. The 0.005 column is the farthest on the right, degrees of freedom of 9, 23.589. That's not right. So we can plug these into the formula. Be careful you don't get these backwards. Okay. This is the confidence interval for population standard deviation. Now, unfortunately, there is not a way to confirm this answer using a calculator.